All right, let's go. So, tomorrow we have a quiz covering just 2A to 2C. So, two-way frequency tables, parallel dot plots, parallel stem plots, and parallel box plots. That's all you need to know for tomorrow. And then the next quiz will cover most of the linear regression stuff that we're doing over the next couple of weeks. All right, so quiz tomorrow, and we're basically just going to keep going. So now I understand some of you have already started working ahead, so that's fine. If you finish 2G or 2H, just keep going. Okay. But if you haven't, then please follow along with our discussion today. So last week we did the following. We put data with two numerical variables into the CAS calculator, and out came this number called R. This number has a name. So let's start with that. What is that number called? Very nice. Okay. So if you see the symbol R, which you will, that's just the correlation coefficient. Okay, so today's lesson, I'm going to introduce one more number. It comes up on the CAS calculator, and that number is called R squared. This is called the coefficient of determination. Now, you might wonder how these two numbers R and R squared, how they are related. And to do that, we need to recall what we mean by taking a number and raising it to a power of 2. What does this mean? Okay, so R squared is the same as R times R. So if I give you the correlation coefficients, you can work out the coefficient of determination because you just got to square it or multiply it by itself. Conversely, if I gave you R squared, I could go back to get R. How would I do that? Yep. Now, there's actually two solutions to that because it's a quadratic. So when you evaluate the square root of R squared, there's going to be two possibilities, a positive number and a negative number. We'll do an example where we need to consider that. Okay, so I've introduced this number called R squared, and it has a particular meaning. And in this subject, you are expected to know basically this sentence. So in the exam, they can give you some data, and they will simply say, interpret the coefficient of determination. And so you need to have this sentence ready to go. And basically, it goes like this. It is the amount of variation in y, that is your explanatory variable, which is explained by the variation in, sorry, not this, this is the response variable. Y is your response variable. So I'll start again. R squared is the amount of variation in y, your response variable, which is explained by the variation in x, your explanatory variable. I strongly suggest you have that sentence written down in your bound reference. Okay, so you might feel like this has come from nowhere. Like, how did I get this? How do I know that that number R, the correlation coefficient, can be used to make a statement like this? It's beyond the scope of this course. I can show you a page calculation if you like, but it's pretty heavy, and you don't need it for this subject. So basically, you kind of just got to know R is a number that comes out of your calculator. R squared is R times R. And then there's this sentence, which goes with R squared. If you know those three things, you're good. So I'll just give you a few moments to get that down, and then we'll do a few examples together. Excellent. All right, so I'm going to do 3 questions with you from 2G. So this is exercise 2G, question 1A. We'll knock some stuff off the work program. So here we are told that the correlation coefficient R is 0.675. Calculate the coefficient of determination. So I'm actually going to do something different. I'm going to pick on people today. So Cooper, do you have a yeah? Yes, you Cooper. What is your suggestion for what we should do here? All right, who do you want to handball it to? Okay, Brian, you've been thrown under the bus. The question is, I'm told that the correlation coefficient in some situation is this number here. I want to calculate the coefficient of determination. Speak up. R times R? Great. All right, so remember, the coefficient of determination is R squared. And R squared is just R times R. So you literally just need to take 0.675 and multiply it by itself. So using your calculator, you can do that. Now, a lot of the time, you'll be asked to present the correlation coefficient as a percentage. So, can anyone tell me what this number is when written as a percentage? I want to convert a decimal to a percentage.
46%.
Okay.
If you round.
Yes? All right. So can you tell us how you did that, Tom?
Just move your decimal point back.
Right. That's the trick. Move it across 2 places. That's the same as multiplying by 100. Okay. So either answer is fine. When you do your exam, most of the time they'll ask for a percentage. All right, I'm going to take a poll. Thumbs up if you're good with this. Middle if you need some time to work on it, and down if I've gone off the planet with this. Thank you. All right, let's keep going. All right, so this is question 2A. So this is basically the same question as what we did just now, except now we're going to write the sentence as well. This last part, interpret, is something you'll probably be asked in the exam. Interpret the value of the coefficient of determination. So I'll do the first part for you. R squared is minus 0.611. 0.611 with a minus sign, that's the correlation coefficient. And to get the coefficient of determination, I just need to square it. Okay, so to the nearest percent, it's 37%. Now this is where you come in. So you may need to refer to the notes we wrote down just a moment ago. I know that R squared is 37%. Now I want you to interpret it for me. And you need to identify the explanatory and response variables as well. every time you are asked to interpret r squared, your sentence is going to look like this, with the blanks filled in. So, can anyone help me out? So we've got scores on a hearing test as the response variable and age as the explanatory variable here.
37%.
Okay, so Tom's off to a good start. We've calculated r squared, so we can just chuck that in.
Oh, the variation in hearing tests is explained by variation in.
Great. So we are using the explanatory variable to do the explaining. So the second part of the sentence needs to go to the explanatory variable. If you reverse the sentence, you've done it wrong. Okay, because we're using the explanatory variable to explain what's happening in the response variable. Okay, so once you've done this a few times, you'll eventually memorize this sentence because you'll have written it so many times. All right, are you okay?
Yeah.
Okay, it's just very quiet. Normally you're very chatty, so that scares me sometimes when the class is too quiet. All right, one more, and then I'll let you have a go at this. So this question here, we've been given r squared, the coefficient of determination, and we've been given the scatter plot as well. There's a reason why the scatter plot is given, because it may change the way you answer this question. Hint, hint. And the question we're asked is, find r, the correlation coefficient. Okay, so we're told r squared is 0.1243. We want to know what r is. Okay. There's an excellent question there. What do you think? So what do you think? So you think the graph shows us that? Yep. So based on the graph, do you think the association, to use a term from last week, the direction is positive or negative? You think it's negative? So are we going this way? We're going the other way, right? So when x is increasing, y is decreasing. So the direction of this association is negative. This means we can't just take the square root of 0.1243 because we'll get a positive number. So if you do this on your calculator, root 1243, you'll get 0.35. So if you wrote r equals 0.35, I would say, oh, so close. But you missed something, which is the direction. So if it's not 0.35, because I've given it away, what correlation coefficient should I report instead? That's right. A negative number because of the direction of the scatter plot. Okay. So I'm going to say the direction is negative. So r equals minus 0.35. So guys, just 1 second. This question comes up fairly often where a lot of students would say, r is 0.35, and they'll ignore the scatter plot. So if you're given information in an exam, you should consider whether you've used all the information that's been given to you. Because if you don't look at the scatter plot, you'll just blindly do the calculation. Okay? So when you're given r squared, there's always two possibilities for r. I don't know how much square roots you will have done in past years, but whenever you have what I will call a quadratic equation like this, there's always two possible answers. So those of you who did methods last year, you know this. But just remember, when you go from r squared to r, there's always two possibilities to check, okay? Don't forget that. All right, so I'm going to give you 20 minutes to work on 2G, and then we'll come back and do 2H together. Have you got a question? You want the aircon? Sure.